All right, let's go ahead and start chapter 1, section 4. This is a section that covers multiplying whole numbers and the expressions that are involved here. So for part 1, let's go ahead and start this. Understanding multiplication. Now, what multiplication kind of, I don't know if, this is more apocryphal or, but whatever. But, for the most part, mathematicians found uh, that repeated addition, when uh, before multiplication was a thing. When was multiplication invented? When was it started? We're not sure. There's no date. There's no person that's attributed to it or anything like that. We're pretty sure that, there is recorded, um, like there's evidence where they show, like, especially in ancient civilizations, that they were doing like this repeated addition, like adding a number over and over and over again. Like they wanted to do 37 times 6. They did 37 plus 37 plus 37 plus 37. Somewhere along the way, multiplication was devised, and that made that whole process of taking an addition problem and repeating it additionally over again, they made that kind of obsolete. However, you could still do it that way, right? But mathematicians found repeated addition was too much work. So yeah, they invented multiplication. All right. So the numbers that are multiplied, those numbers, when you're doing a multiplication problem, like, something pretty simple, like 3 times 4, those are called factors. 3 is called a factor, and 4 is a factor. Okay. Um, when you answer it, that's called the product. Okay. So 3 times 4 is 12. So the product is the solution. That's the answer to a multiplication problem. All right. So in this next part right here, let's kind of go through this. If you want to, a lot of times when you're doing these notes, if you want to, feel free to pause the video and kind of try these on your own and then see if it matches up with what I'm doing. And you can skip through whatever parts you feel like or you don't, that you've already seen before. But on this first part, what we have is the product of 2 and 3. So what is that as a translation into symbols? So that's pretty easy. That's just 2 times 3, right? I used a dot right there. That's called a binary symbol, but it represents multiplication, right? We can also use an X for multiplication. We can also use parentheses. A lot of different ways you can express multiplication. I'm not going to do all different ways every time, but that's what you can do. The product of X and Y. Well, if you're um, dealing with algebraic, variables, we could just write X, Y like that. You can just write X next to Y. That implies multiplication. So you can write it like this as well. I know I just said I'm not going to do that, but you can do it like that. You can use parentheses. All right, here I am doing what I said I'm not going to do. But yeah, I think it's good for you to see that either way. All right, 6 times a number. All right, like that. 6n. There you go. Double a number. Now that's a specific type of multiplication problem. That means times 2. So 2, I'm going to use some different variable than n. How about c? Doesn't always have to be n. Could be x, could be y, could be a, could be any letter in the alphabet. Twice a number, that means the same thing, right? That means 2 times g. Why not use that? Triple a number means you're multiplying by 3. 3 times n. Okay. For part 2, now practice multiplication. So like right here, now I just have a grid here. When I do this in class, I just, this is the way I learned multiplication. My teacher kind of gave us kind of a lattice, kind of this thing where you have, or it's not a lattice, it's called a matrix. And you just put the numbers in there, you line them up, you line them up by place value, 5,278, and you're multiplying that by 304, which is a good way to do it, because especially when you're younger, you're not as neat, perhaps maybe not as organized, even maybe at your age now. Yeah, things are kind of hard to line up, and that things can get messy, especially with a multiplication problem like this. You can definitely see, like, because you're going to have 3 rows of numbers, because you have a triple digit here factor, 304. you're gonna have to do 3 rows of products here. So that can definitely, as if you're not lining everything up, that can get messy and it can get unorganized, and you can accidentally have numbers lined up wrong, perhaps, or just in a way that you don't want them to be. All right, so I'm just going to kind of go through this now. Everything's going to be multiplied by 4. So 8 times 4, 7 times 4, 2 times, we're just going to do that. So 8 times 4 is 32. Kind of how I do it. All right, 7 times 4 is 28 plus 3. Add the 3 that we added up there. 28 plus 3 is 31. So I'm going to write 31 like that. All right, 2 times 4 is 8, and 8 plus 3 is 11. Carry the 1 over there. All right, and then 5 times 4 is 20, plus 1 is 21. There you go. All right, and then as you may or may not know, hopefully you know this, but as you start another row, because now we're multiplying everything by this number. Now that number is in the tens place, right? The 4 that we've multiplied first was in the ones place. But when we're multiplying everything by the tens place, we need to put a 0 here. Now the 0 sometimes might be called a placeholder, but there's a reason for that, because whenever you multiply a number by 10, right, you're gonna have a 0 on it. But that kind of works out the way that does. Now, we're multiplying everything by 0. However, when you multiply by 0, it's 0, right? So 8 times 0, 7 times 0, 2 times 0, 5 times 0. So a bunch of zeros there, all right? But it's a necessary thing you want to do, all right? Now we're going to multiply everything by 3. Now that 3 is in the hundreds place. That 3 is in the hundreds place. Therefore, we're going to put 2 zeros, because 100 has 2 zeros right there. And then, so 8 times, and it doesn't hurt what I'm going to do here. Get rid of these numbers, because we're sometimes likely to confuse those with numbers that we're carrying already. So it's good to get rid of those. Use your eraser or whatever. I'm just crossing them out just so that I told myself that I got rid of them. So we're multiplying everything by 3 here. We're multiplying everything by 3. So 8 times 3 is 24. So I'm going to put the 2 above the 7. All right, 7 times 3 is 21. 21 plus 2 is 23. So put the 3 there, carry the 2. All right, 2 times 3 is 6. 6 plus 2 is 8. Okay, and nothing carried on that one. And then 5 times 3 is 15. All right, just had enough room. I should have probably written that further over to the right. All right, and now I'm just going to add everything up. Add up all the columns. So add this column. Now that makes 2 plus 0 plus 0 makes 2. All right, add up this column. That makes 1. Okay, pretty easy addition right there. All right, we're going to add up this column. That's 1 plus 0 plus 4. That makes a 5. All right, and then just keep doing this. Keep adding. All right, 1 plus 0 plus 3. That makes 4. Okay, that makes a 4. And 2 plus 8 makes 10. So I'm going to put a 0 there, and 10 carry the 1 over. All right, 1 plus 5 makes 6. Nothing carries, and then there you go. So there is your product. 1 million, put a comma every third digit. 1,604,512. All right. Yeah. All right. So know how to do that. I know like most of us use our calculators for math and stuff like that, but I mean, you should know how to do that without a calculator. Even though when we were younger, you were told, especially when I was younger, you're not always gonna have a calculator, around. And how wrong were they? Not only do we have a calculator, we have like a supercomputer, handheld supercomputer, essentially in our possession at all times with our smartphones. So yeah, they were really wrong about that. Anyhow, for part 3, we've got dealing with trailing zeros. All right, so you got 842 times 400. So what we're going to focus on here is this number, this factor right here, 400 that we're multiplying by. We can ignore those zeros. We can kind of just kind of get rid of those. Well, I mean, I wouldn't say get rid of them, but so you got like 842, and then when we multiply that, we can put the 4 there, and then we can kind of put the zeros off to the side. Okay, now those zeros are important. I'm going to underline those too. Those zeros are important. They're still part of the product. They are definitely a part of the product. But we can kind of just leave those off and just know that there's going to be 2 zeros at the end of our product. All right, and then just do the multiplication. So 2 times 4 is 8. All right, 4 times 4 is 16. Carry the 1. 8 times 4 is 32. 32 plus 1 is 33. So there you go. 336,800. That's what that is. 336,800 is the product. Easy enough, right? Okay, now for part 4, this is we're setting up an array here. So okay, we've got a customer has a choice of 5 carpet colors: blue, white, pink, brown, purple, and 3 colors for wall paint. Okay, so 5 colors. All right, what I'm going to do is I'm going to set up the colors of the carpet on the top here. So I'm going to start right here. I'm going to start one over and you'll see why. So I got blue. I'm going to put white. Right. Oh, wait, what am I doing? No, I'm not going to do that. Let me do it this way. I don't have enough columns. Let me do it down way. I'm going to go down. So we got blue. Forgot about that. White. I'm going to put white here. All right, I'm going to put pink here. I should be drawing. I should write using the colors of that, but whatever. All right, we've got brown. And we've got purple. All right, so you got that. And then the colors of wall paint, we've got 3 colors of those, which is white, and we've got yellow, we have least favorite, and then we have light blue. It's a nice warm color. All right, and so what this is essentially what we're just doing here, and this is kind of this is in the multiplication section, but this is more or less kind of a probability strategy. Like a lot of times in probability, when you want to figure out outcomes and stuff like that, you set up an array. Because ultimately probability, a lot of times when you're doing probability problems, you're looking for, like you're finding the number of factors, you're looking for the product of outcomes. A lot of times it has to do with factors. Because there's this thing called the counting principle where you take the number of choices and you multiply that by the number of choices of the other thing, and that's how many choices total there are. So yeah, so we're like right here, we're going to set up an array to show all the possible combinations of carpets and paint colors. Okay, so like right here, we've got blue and white. That's what we're going to do here. So we've got blue, yellow, and we've got blue and light blue. Easy enough, right? And then right here, I'm just going to do all the combinations of white carpet. So we have white carpet with white paint. Okay, that's the color of an insane asylum. All right, and then you've got white carpet with yellow paint, I guess. And we've got white with light blue. Now just kind of go through this. All right, so we got pink. I'm just going to write pink a bunch of times here. Pink, pink, pink. All right, and then we've got pink and white. Pink and, oops, I wrote white for some reason. Yellow. And we've got pink and light blue. Oh, that is that. All right. All right. Brown carpet, white paint. Brown carpet, yellow paint. Brown with light blue. Paint. All right, and then our last one, purple with white. Purple with yellow paint. I don't think that matches very well. Or maybe it does. I don't know. I'm not good with color combinations. All right, purple and light blue. All right, that does it. Okay, that does it for section 4.